Welcome to Jacket Academy Math Day 1. We're going to be using your ACT Prep workbook that you should have a copy of, but if for some reason you ever lose it or can't find it, I want to show you where to find it online. On the ACT.org website, we have free test prep resources, and underneath that you see Preparing for the ACT. It's a PDF document. When you click on that, it's going to open up the PDF version of the workbook that you should have been given a copy of. In this workbook, you guys can write in yours as I'm writing in mine up here, and we're going to be working through several questions each day to get you guys thinking more along the lines of standardized testing. This first example says, the blood types of 150 people were determined for a study as shown in the figure below. If you look at the figure, along the x-axis it shows the different blood types. If you look along the y-axis, it shows you the number of people with each of those blood types. Then it says, if one person from this study is randomly selected, what is the probability that this person has either type A or type AB blood? Looking at the graph, type A blood, there are 67 people. Type AB blood, there are 6 people. So the number of people with either one of those would be 67 plus 6. So 73. Then I want to know how many people there are total, because probability is going to be representing how many people have those types of blood out of how many total people were asked. And they told us here that 150 people were asked. So 73 out of 150. If I look at my options here, I see that as choice D. Be careful, because sometimes if your fraction could be simplified, you won't see this fraction as one of your answers. You'll have to simplify that fraction first before you look for it as an answer. So we added A and AB together and then wrote it out of the total number of people that were asked. If you look at number 2, it says the monthly fees for single rooms at 5 colleges were $370, $310. It gives you the prices for each of them. Then it asks, what is the mean of these monthly fees? The mean is another word for average. And the average is found by adding them all together, which is called a sum, and then dividing it by the number of, in this case, rooms. So we want to add all of these together. I'm going to add 370, 310, 380, 340, and 310, which is $1,710. And then divide that by how many rooms we looked at. It said there were at 5 different colleges, so I'm going to divide that by 5. So 1710 divided by 5, which is 342. So on average, the single room at a university costs $342, which is choice H. Number 3 says on a particular road map, 1/2 inch represents 18 miles. About how many miles apart are 2 towns that are 2.5 inches apart on the map? The easiest way to do this is going to be to set up a proportion of 2 equal fractions. And the easiest way to put fractions is if you don't already have fractions. So what I'm going to do is call this 0.5 inches, and I'm going to call this one 2.5 inches. And I'm going to set up a proportion where I'm saying that on the particular road map, the scale says that every 1/2 inch or 0.5 inch represents 18 miles. And now my proportion is going to be 2 equal fractions where I'm going to say 2.5 inches is equivalent to how many miles, or x miles. Notice that in my proportion, when I'm setting up 2 equal fractions, I want each of my units to match. Inches on top, miles on bottom, or if you wrote it backwards, you could always do that as long as you did the second fraction the same way, because I want them to be equal or equivalent. Whenever I have a proportion, I'm then going to cross multiply, where I'm going to multiply the numerator of one and the denominator of the other. So this is going to say 0.5 times x equals 2.5 times 18, which is 45. Then I want to solve this for x. So to get rid of multiplying by 0.5, I'm going to divide both sides by 0.5. So 45 divided by 0.5 gives me x equals 90, and this is in miles. We're saying that 2.5 inches on the map represents 90 miles in real life, and you see that as choice E. Number 4 says, given that f equals c times d to the third power, or cubed, f equals 450, and d equals 10, what is c? I'm going to start off with the equation f equals c times d to the third power, and I'm going to plug in the things that they've told me. F equals 450, that equals c times 10 to the third power, and then I'm going to start to evaluate or solve wherever I need to. I'm going to start with this 10 to the third, so this is going to say 450 equals c times 10 to the third power, means 10 times 10 times 10, which is 1,000. So c times 1,000. But I want to know what c is. So if I want to solve this equation, I need to get rid of multiplying by 1,000, and to do that I would divide both sides by 1,000. So 450 divided by 1,000 equals 0.45. And if I look at my options, that is the very top one, F. Number 5 is similar to that, only it's written a little bit differently because number 5 is in function notation. And in function notation, it's your job to make sure that you know how to read what the question is asking. What they're telling you in number 5 is that you have a function, and here is the function, 3x plus 7, that whole quantity is squared. Then it asks, what is f of -1? I'm sorry, +1. F of +1 is found by taking out the variable x and replacing it with the number 1. So I'm going to rewrite the function, but I'm going to take out x and replace it with 1. So 3 times 1 plus 7, and then all of that gets squared. If I'm doing this by hand, then I have to make sure that I remember order of operations starts with grouping symbols, and I work within my grouping symbols. If you have a scientific calculator, you can simply put this in all at once using parentheses, 3 times 1 plus 7, and then close your parentheses and square it, which gives you 100. If you were doing it by hand, that would amount to 3 times 1, which is 3, plus 7, which is 10, squared, which is 100. So same thing, just a matter of whether you're doing it by hand or on the calculator. Number 6 says Jorge's current hourly wage for working at Dinty Smiles is $12. Jorge was told that at the beginning of next month, his new hourly wage will be an increase of 6% of his current hourly wage. What will be Jorge's new hourly wage? Well, he started out at $12 per hour. We want to find out what 6% of that is so that we can add it back on. So 6% as a decimal is 0.06. When you're changing it from a percent to a decimal, you move the decimal 2 places to the left, so 0.06. We're going to multiply that $12 by 0.06. If you have one of the TI-30XS Multiview scientific calculators that we push really hard starting in Algebra 1, it actually has a percent button on it where you wouldn't have to change the 6% into a decimal. You could use 6, and then the percent button is found by hitting second and then left parenthesis. There's a little green percent over the top of that. You could just put in 6% times 12. If you don't have that, or if you can't find it, you can always change it to a decimal and multiply it by 12. What that amounts to is 72 cents. And so what we're saying is that he's going to make a 6% increase over his currently hourly wage. So we're going to add on 72 cents. So he will now earn $12.72 per hour, which is choice H. Looking at number 7, it says the first term is 1 in the geometric sequence given. What is the 7th term of the geometric sequence? One of the things that we learn about in Algebra 2 is geometric and arithmetic sequences, but a lot of times the formulas are not something that we either have a reason to commit to memory or something that we can remember easily, and so we oftentimes forget them. So what's important in a question like number 7 is that you know how to answer it without having to know a formula. So it says the first term is 1. You're basically dealing with a pattern. And so you want to figure out how you get to the next number from the last number. So you're looking from 1 to -3. Well, I multiplied by -3. If I continue multiplying by -3, I get +9, I get -27, and so I can figure out what's happening each time. They want to know what the 7th number is, or the 7th term. And so without having to know a formula, I know already the first 4 terms. So I would just need to continue multiplying by -3 to get the 5th, 6th, and then the 7th term. And that's going to be the one I want. So if I do -27 times -3, I get +81. That's going to be the 5th term. If I multiply that by -3, I get -243. That's going to be the 6th term. And if I multiply that by -3, I end up with +729. So +729 would be the 7th term of that sequence. Geometric means that we're multiplying by the same number each time, whereas arithmetic means that we're adding the same number each time. Looking at number 8, it says the shipping rate for customers of ShipQuick consists of a fee per box and a price per pound for each box. The table below gives the fee and the price per pound for customers shipping boxes of various weights. Greg wants ShipQuick to ship 1 box that weighs 15 pounds. What is the shipping rate for this box? So if we look at the table, here's the weight in pounds. We want 15 pounds, which is in this 10 to 25. It's going to be a $10 fee plus 65 cents per pound. So I need to multiply that by how many pounds there are, or by 15. So don't forget that I'm adding the $10, the fee, plus 65 cents per pound. So I'm multiplying that by 15 pounds. So 10 plus 0.65, don't forget that it is 0.65 because it's cents, times 15 for a total of 1975, or choice H. Number 9 says that a computer chip is 0.32 centimeters thick. It's made up of layers of silicone. If the top and bottom layers are each 0.3 and 0.3 centimeters thick, and the inner layers are each 0.02 centimeters thick, how many inner layers are there? So the total thickness is 0.32 centimeters. I can go ahead and I can take off 0.03 for the top and 0.03 for the bottom so that I know how much I'm dealing with for the inner layers. So I'm just doing 0.32 minus 0.03 minus 0.03, and I find out that there's 0.26 left. That's for the inner layers, but I know that each of them have to be 0.02 centimeters thick. So what I'm going to do is now divide that by each of the thicknesses of them. So divide it by 0.02, and I end up with exactly 13. So there are 13 inner layers. Number 10 says the table below shows the number of cars Jing sold each month last year. What is the median of the data in the table? So the median represents the middle. If it helps, think of it as like the median when you're driving. The median is what separates the middle of the 2 lanes. And so we want to know the median of the data. Before I can find the middle, though, it has to be ordered. So I have to list all of this in order, which is sometimes time-consuming, and it can be a pain. So what I usually do is start by looking for the smallest one, and then either I mark through it or I put a check mark next to it or something so I don't accidentally go back and count it again. But I'm going to write these down in order, starting with 13, 15, 16, 19, there's another 19, and then my next is going to be 22, and there are 2 25s. I have a 26, 27, 28, and 29. And now I want to find the middle of those. The middle, I'm going to work my way in. Probably the easiest way is to go one at a time from each side. So I'm actually going to go 2 from the left and 2 from the right, 2 from the left and 2 from the right, 2 from the left and 2 from the right, and notice that I've marked everything off, which means my number is actually halfway between 22 and 25. So what I'm going to do to find that middle between 22 and 25 is add 22 and 25 together and divide it by 2. That's the same thing as finding the average or the mean of those two numbers. So 22 and 25 added together is 47, and then divided by 2 is 23.5, which is choice K. Number 11 asks, here is the student studying motion. They observed a cart rolling at a constant rate along a straight line. The table below gives the distance, d, feet, the cart was from a reference point at 1 second intervals from t equals 0 seconds to t equals 5 seconds. So what they're saying is when there was no time had passed, it was 14 feet from the reference point. After 1 second, then it was 20 feet. After 2 seconds, then it was 26 feet, etc. So kind of like we did earlier, we're going to be looking for a pattern. And what I notice is that each time it's going up by 6 feet. So as time passes, we're increasing by 6 feet each time. As I look at the equation, that 6 is represented by the number of seconds. So 6 times t. 6 times 1, I added 6. 6 times 2, I added another 12 from the beginning. 6 times 3, I added 3 6s from the beginning. So that's where that 6 is coming from. But I also need the reference point in general, and that is that very beginning number, or our starting point, 0, and I add on a 14 for that. If it's easier for you to think of it less like an equation and more from the table, what I can do is take these t values and actually plug them into the options to see which one gives me the correct distance. For instance, if you plug in 0, 0 plus 14 gives you 14. But if you plug in 1, 1 plus 14 gives you 15, not 20. So you can get rid of that as a choice. Same thing for part B. If you do 6 times 0, you get 0 plus 8, which is not 14. 6 times 0 gives you 0, plus 14 gives you 14. And then this is the one that we said was going to work. So if you do 6 times 1, you get 6, plus 14 gives you 20. So we know that C works. C is our correct equation. In the next video tomorrow, we will be looking at the next set of questions still in your ACT workbook. So what I would like for you to do is to work ahead at least 5 questions. We're going to try to hit 10 questions tomorrow. So if you could work through all 10 of them, get as far as you possibly can, or at least try each of the questions, then you'll have a heads up and be able to learn more from what we go over in the video tomorrow. Have an awesome day, Yellow Jackets.